Hello, everyone. In this video, I will be walking you through a multi-level structural equation model, and we will be examining indirect effects at the within dyad level. All right. And so what we'll be doing here is using dyadic data from a sample of roughly 186 heterosexual couples, be looking at the indirect relationship between childhood maltreatment and the quality of the couple relationship with common dyadic coping and relationship mindfulness serving as parallel mediators. All right, so you can see here, we this is the diagram of the model that we will be running, and we will be using Mplus in this demonstration. And so, as you can see, what we'll be doing is testing the indirect effects, looking down here at the within dyad level of childhood maltreatment, so CMW, and to the relationship quality also at that within level. And again, with dyadic coping and relationship mindfulness serving as those mediators. And so what we are doing is that dyadic coping, relationship mindfulness, and relationship quality, those are variables that are all measured kind of at the dyad level. So what I mean by that is the items in each of these scales references the relationship that both partners respond to. So rather than partners reporting on their own behavior and partners reporting on their partner's behavior, they're reporting on the relationship. All right, and so that's really what allows us to use a multi-level SEM model to disaggregate and pull apart what is unique to each individual within the relationship and also what is shared between both members of the dyad. All right. And so that applies to both mediators and our outcome variable, but that does not apply to childhood maltreatment and some of our covariates. Because if we think about conceptually what childhood maltreatment is, it's abuse and neglect in the first 18 years of life, and it happens to each partner, right? And so when maltreatment occurs, when there's physical abuse or sexual abuse or whatever it is, that's not something that's not necessarily a shared experience. Even if they were siblings within the same household, one is kind of a direct victim and one is kind of exposed to the maltreatment. So there's still very different experiences. All right. And so this makes maltreatment a within dyad variable. And so what that means is that um, each partner will have their own score on maltreatment, and it is presumed that there is not a kind of dyad level experience of childhood maltreatment. Um, and again, this is because the dyad level represents things that are shared between partners. And that's why it's so important to have measures that assess the relationship, because the relationship is shared between the male and the female partner in this. Whereas the experience of childhood maltreatment, it is not shared by the male and the female. All right. They occur essentially completely independently of one another. Although we will find or we do find, I should say, that reports of maltreatment are positively correlated with one another. So the higher one partner is on maltreatment, the higher the other partner is on maltreatment. But that doesn't necessarily mean that they are, interdependent on one another, right? And so, again, everything that happens at the within dyad level, um, each person has their own unique score, and it's based on their individual level experiences and reports and things of that nature. And everything at the dyad level is shared between partners, a shared experience, a shared context, or something that happens to both dyad members. And again, that's why we have dyadic coping, relationship mindfulness, and relationship quality at the dyad level, because the relationship is that shared experience for both members, right? And so we'll actually move over here into Mplus. And the first thing that we are going to do, and we're only going to do this for one of the three variables, and that is compute the interclass correlation. So one of the benefits of multi-level structural equation modeling is it can pull apart within dyad effects or what, dyad member to dyad member variability in maltreatment, in age, in whatever other variables you want to throw in there from between level effects, right? And so again, we can pull apart what differentiates couple to couple to couple at the between level and what differentiates the male from the female partner at that within level. All right. And again, if you're familiar with multi-level modeling, you've probably heard a lot about the intra-class correlation. So really what this allows us to have is a much more nuanced perspective to what is happening in romantic relationships. Because as is, most, if not all, research on couples or other kind of dyads, especially within, the family science literature base, um, they don't disaggregate the within and between dyad effects. And so if you've ever heard the term smushed, what happens is when we have our parameter estimate, just like a basic actor-partner interdependence model, it's actually combining within dyad and between dyad variability. And so that results in biased parameter estimates. So we're kind of pushing within and between level effects together and saying this is simply the between level because that's what any actor partner interdependence model that you run in multi-level modeling or in structural equation modeling is getting at person to person differences in the effect of the IV on the DV. We're not necessarily pulling apart um, any more nuance there. And so that's really what multi-level structural equation modeling allows us to do. And so what we'll do is we have the common dyadic coping subscale. So this is from the dyadic coping inventory. And so that subscale references how partners deal with stress together. Other questions within the DCI, they're going to be self-referential, a person reporting on their own behavior. They're going to be partner referential, how a person perceives their partner to be responding. But again, these 5 questions, it's items 31 through 35, they are referencing the relationship itself, which is why we can use a multi-level SEM because there are 2 different sources of variability. What is shared with the partner at the between level and individual differences between partners at that within dyad level. All right, we have a little bit of missing data here. And so we will specify -999 as our code. You have to have a grouping variable, a clustering variable. And so what we have here is a dyad ID. And so the male and female partners from each dyad are going to have that same dyad ID. All right. And to run the interclass correlation, we'll just do type equals 2 level here. So we're essentially using just multi-level modeling here. We're going to use maximum likelihood here. We will actually shift it over into a different estimator when we run the full model. And then I have specified 10 using 10 processors because we will see these models can actually take quite a bit of time to run. And so this is just kind of default when I'm running multi-level or multi-level SEM models. So in Mplus, you have the within, right? This is the within command. So this is the within dyad command. So what's happening kind of at level 1. And then we have common dyadic coping. And so what I'm doing here is I'm just specifying that this is a variance in Mplus. By simply just typing in the variable name followed by a semicolon, that is Mplus's way of understanding I want to estimate a variance or the within dyad variance, right? And I'm going to do the same thing at the between level, all right? And so again, I want to pull apart sources of variation in common dyadic coping to what is shared with the partner at level 2 versus what is individual and different between partners at level 1. All right, and then if you just do SAMstat, and I always have standardized estimate as a default, we can go ahead and save this and we can run it. And it should run exceptionally quick. We can kind of ignore uh, these this output here. Essentially, what this is saying is that for a cluster or for dyad 14, 17, 20, 21, etc., that means that the male and female partner have the exact same scores on the dyadic coping inventory, and that would be expected um, in this type of analysis. All right, so we'll scroll down and we don't have to scroll very far. And in the summary of the data, we will get our intra-class correlation. All right, and so we have an ICC of 0.617, which means 61.7% of the variance is due to dyad differences or between dyad differences. And this is fairly standard in dyadic data. When for a lot of people use multi-level modeling with like educational research, and you tend to see much smaller inter-class correlations, students nested within classrooms, but those students come from different homes, they live in different contexts and things like that. So it's not surprising that the ICCs, tend to be, 0.05, 0.10, 0.15, 0.20 if you're doing really, really well. But when we have people in a committed relationship, there's extremely high levels of interdependence between romantic partners. There's not necessarily really high levels of interdependence among students in a classroom, right? And so this tells us we actually need to disaggregate these effects. We need to use a multi-level model of some kind, right? And we would want to do the exact same thing for our relationship quality variable, so this one, and our relationship mindfulness variable. But I'm not going to walk you through those demonstrations because, again, you get the gist, and you would just replace common dyadic coping with relationship mindfulness and relationship quality, and both have substantial ICCs. All right, so we will, now that we know we have, substantial variability but at the dyad level and at the individual level, we can proceed to our multi-level mediation model. So again, I'll go back to the figure really quickly as we tested the ICC on this variable. And we see that there's a significant amount of variance up here, and there's a significant amount of variance down here. And again, I didn't demonstrate it, but we have the same things for these two variables, which tells us, again, we really need to pull that apart to see where the effects are actually occurring. All right, so next we are going to specify this model where we are going to have our IV, our DV, and then mediator one and mediator two. Again, I'll move it so it looks a little bit prettier. So maybe because this can be hard to differentiate into diagram, but essentially it looks kind of like this. So we have kind of two mediators rather than serial mediation with maltreatment predicting relationship mindfulness, predicting dyadic coping, predicting relationship quality. We are ascertaining the unique effects of dyadic coping and relationship mindfulness in the prediction of relationship quality among folks with varying levels of childhood maltreatment. All right. And so what the within-dyad model will give us is partner-to-partner differences, and the between-dyad will give us what is shared between partners. And so we're going to also include several covariates because that can often be really helpful in understanding these multi-level SEM models, because when you're first starting out, it can be exceptionally difficult to kind of wrap your head around the disaggregation of effects, understanding, within dyad versus between dyad associations. And hopefully by including some of these covariates, that can help us get a lot of clarity around what these models are doing and what the interpretation of these models are. All right, so we are going to have our four major variables that are going to be involved in our mediation model, and then we are going to have three control variables. All right, so age, gender, and the number of children the dyad has together. And so we will tell Mplus through the use variables command that we want to use these 7 variables. We have a little bit of missing data. We have our clustering variable. And then this is where we begin to kind of dive into the weeds a little bit. I'm actually going to start down here at the model, and then I'm going to come back to this within and between command. So we are actually going to be using Bayesian estimation here, and it's going to be a two-level model. And then we are going to be using 100,000 different replications. So it's kind of analogous to like a Monte Carlo bootstrapping procedure, right? And again, I'm using 10 processors to speed up the estimation because I am estimating so many iterations. Generally, I start with, probably 10,000 iterations, and then once that model seems to be fitting quite well, I'm getting, a decent PSR value, and things like that, then I will up my iterations just to ensure that I'm getting a good solution. So if anyone has ever done mixture modeling and latent profile or latent class analyses, one of the biggest problems in those analyses is that we can get kind of local minima. So the solution that Mplus spits out isn't actually, the population level estimates. Rather, it's something local that is more specific to our data. And so, how we combat that in latent class and latent profile analyses is by having random starts. And so, we're going to have the Mplus software start a bunch of different places in terms of finding the best parameter estimate. Right, so it's kind of like the same procedure if you've done some mixture modeling. Again, it's not exactly the same, but it might be a way to kind of connect what these iterations are. So we're going to start at the within level first. All right, and so for our variables, CSI, relationship quality, relationship mindfulness, and common dyadic coping, these are the variables that we're disaggregating. All right, so these are variables that we're going to be estimating at both the within dyad level and the between dyad level. And so we will obviously see them at the within dyad level. And so this is basic Mplus syntax right here, right? So our dependent variable using the on statement as regression. And then we have our first dependent variable, or independent variable, I should say, which is in this case our mediator, and our second independent variable. And I'm throwing labels on here because we are going to need those for testing the indirect effects. If you're used to Mplus, you've probably used the model indirect command. That's not necessarily going to work here because in this model, I should say, we're going to be testing indirect effects only at level 1, but you could theoretically be testing indirect effects at both levels simultaneously. And the model indirect effect can get a little confused. And Mplus, I haven't used it in a while, might even yell at you and give you an error message if you try to use the model indirect command when you are using the within and between disaggregation technique. All right, so relationship quality being predicted by relationship mindfulness and common dyadic coping. It's also being predicted by childhood trauma directly. So if we go back to the diagram, actually, I forgot to include this path. We have a direct path here, which we are going to test. So that means we are really hypothesizing partial mediation so that there still might be an effect from child maltreatment to relationship quality, independent of the effects of dyadic coping and relationship mindfulness. That's kind of what we're hypothesizing here. All right. And we also have childhood trauma, childhood maltreatment predicting our two mediators. And so again, I have these commands on separate lines because in Mplus you can theoretically do something like this, where you have two dependent variables on the left-hand side of your on statement. But again, we want to test those indirect effects and we need the value labels for that. So I have it on two different lines. But essentially those two lines of syntax are these effects right here: maltreatment to dyadic coping and maltreatment to relationship mindfulness. All right, and here we have our kind of covariate statements. So we have our independent variables, or I guess I should say mediators, and our outcome variables being predicted by gender and age. So that means gender and age are accounting for person dyad member to dyad member differences in common dyadic coping, relationship mindfulness, and relationship quality. Because we are testing kind of a parallel mediation model and we have two mediators and it's not sequential, it's not one mediator predicting the second, we need to throw a with statement in there. All right, so that is this guy right here, this guy between dyadic coping and relationship mindfulness. And you will actually commonly see multi-level SEM models look like this because they can get exceptionally messy when you have all of these variables kind of in the traditional way of demonstrating a mediation model. So if you were to do something like this, again, as you can see, it gets really, really ugly, really, really wonky. And so this is how a lot of folks choose to display their models. So it's not as intuitive, but it does make it look quite a bit nicer. All right, and then just as in we normally would in Mplus, we have our independent variable and our two covariates, which again, Mplus doesn't really care what we call them. It just knows that they're exogenous predictors. And so we're going to covary them with each other. All right, and so all of that is happening at the within level. All right, and so now we're going to shift our attention to the between level. And so we will see relationship quality, relationship mindfulness, and common dyadic coping up there to examine dyad to dyad differences at the between level. And we have another covariate, which is the number of children that the dyad has together as only a level 2 covariate. So you'll see up here, there is absolutely no mention of this variable. Well, why is that? Well, if we think about the number of children that a dyad has together, those partners are going to have the exact same value. So if the wife has two children with her husband, the husband's going to have two children with the wife. So there's going to be no within dyad variability. The variability is literally going to be zero because they have the exact same score on that variable. And so if we were to include this at level 1, either it would spit out an error message and it wouldn't even converge, or the model would converge, but we'd see a whole bunch of mess in our parameter estimates and our standard errors because at the within level, the number of children is actually a constant. All right. Again, there's no variability there. And so we only have that at the dyad level because couple 1 could have 0 children together, couple 2 could have 5 children together, couple 98 could have 3 children together, right? It can vary from dyad to dyad to dyad, but it's not going to vary within dyad. Right. And then we're going to throw a simple covariance on here as well, all right, to correlate those two exogenous predictors. So you'll notice is that at the within level, at the within model, we have childhood trauma, gender, and age as exogenous predictors, but they only exist at the within level. All right. And so essentially what that means is they're not included at the between level because none of these variables have a shared component to them. All right. None of these variables affect both partners, right? So one partner's history of maltreatment isn't directly affecting the other person's history of maltreatment. One person's age isn't directly affecting another dyad member's age. There's not, again, not a shared component. And so that way, up top or up north at the between level, we have our relationship mindfulness and common dyadic coping actually as our exogenous predictors. Again, look up here. These are the exogenous predictors. These are not being predicted by anything else, unlike down here where they are being predicted by maltreatment and the covariates. So we could theoretically have, we have, a number of children. We could theoretically have a number of children if we think that's a predictor of dyadic coping and of relationship mindfulness and what will kind of differentiate couple to couple. So there's no reason kind of that we can't do something like this. But that's not really the research question that we have here. Our research question is not really about does the number of children differentiate how well couples cope together and how mindful they are when they communicate with one another, right? So again, theoretically possible, but again, not the goal of the current investigation. And so I will go back up top, and that's where we now kind of go to the within and between commands. What Mplus is going to assume by default is that if you don't specify a variable at the within or between level, it occurs at both levels. So you may have even kind of maybe noticed that kind of reflecting back on the ICC, right? We had a common dyadic coping at the within level and at the between level. All right. And so that, again, implicitly, we're telling M plus, since it's not just at the within, it's not just at the between, it can be parsed apart, the variance can be, to be, again, at the within and the between levels. So again, it's going to be really, really important to know where your covariates go in your model. Is there going to be dyad to dyad variance in your covariates? Is it going to be within dyad variance, or is it going to be both? Right? Because again, really flexible model, but we need to know where to put things correctly. All right, so we have another covariate up here that's not included in our model, but like depressive symptoms. So this is where things can get a little sticky. Is depressive symptoms are each individual is probably going to vary in their level of depression, right? So again, that makes sense. But also when we think about depression, we might think about like the emotional climate of the relationship, right? So we might say that it's a very kind of depressed relationship or a boring relationship or a hopeless relationship or a whatever type of relationship. And so we could add in this as like a mixed, a variable like, or a covariate that we can disaggregate into within and between level of variance. But and it might, and who knows, it might even work. But the problem with including kind of an individual level covariate that might be theoretically related, to the dyad at the between dyad level is that there's an additional level of abstraction that's happening. We are inferring that a relationship level of depression is a common cause of each dyad members levels of individual depression, and whatever's left over, whatever is then is not commonly caused by relationship level depression, are the individual differences. So this is where you're kind of thinking like a common fate model, where those individual departures from how depressed the relationship is would be found in your residuals. All right. And so again, it might, I would theoretically argue that there is an emotional climate to relationships. But I would also argue because of the levels of measurement, because we are using self-referential items, my hopelessness, my changes in eating, my sadness, my suicidal ideation, that we are not actually getting at that dyad level process. And so that would be at the within level. So if I was including depression here, it would go at that within level. Right. Instead, we need to develop a measure that's based on the conceptual idea that relationships can have their own personality, their own emotional climate, and we again develop a measure and use multi-level SEM to use factor analysis to derive and to validate those types of scales. Right. And so we know at the within level. We actually have gender in this example, and I'll talk about gender here in a second, because all of our dyads are heterosexual, right? So there's only going to be variability between partners in terms of gender, but every single couple is heterosexual. So that means there's going to be no dyad to dyad differences because, you can imagine there's like an imaginary variable in our model or in our data set that says, are you heterosexual? And, 0 equals no, 1 equals yes, well, every dyad is going to have a 1. So it's going to be a constant. So when you're using only heterosexual couples, gender is actually only at the within level. You have a male partner and you have a female partner, so you have some variability there. But if you were using, LGBTQ, gay and lesbian dyads, that's where gender would now flip to be a between level variable. So what I mean by that is at the within level, with lesbian couples, it's going to be two girls, and gay couples, it's going to be two guys. Well, there's no variability between or within a couple, right? They both have zeros if they're let's say male, and they'll both have ones if they're female. So there's no variability there to tease out or to parse out or to disaggregate. But what we do know is that when comparing couple to couple to couple to couple, we have some couples that just have male partners and some that just have female partners. And so that's where we would put gender, is at the between level if we were using gay and samples of only gay and lesbian couples. And you could even theoretically, with gender identity becoming more and more commonly measured on a spectrum, you could actually disaggregate potentially gender identity as an important potentially predictor in your model. Then of course you couldn't use it as your distinguishing variable like we're doing here. But again, you could actually disaggregate gender. Again, to what extent that's actually an important research question in the context of like dyadic coping and relationship mindfulness. That's for the theoreticians to really parse out, but it could theoretically be done, right? So again, likewise, age is unique to each partner. They could be the same age, they could be a different age, but their age is their age, and it's only going to differ again at the individual level because I'm not sure what couple level age is. Now, if we were interested in something like that, we have a relationship length variable, and we could throw that at level 2. Okay, we could add that into our model because the couple, again, most of the time, they're going to agree that they've been in a relationship for this specified amount of time. What you'll actually find in practice is that relationship length reports from male and female correlate at point like 9.5. So there is a little bit of variability where someone says we've been together 18 months and another partner says we've been together 19 months. So you either take a dyadic average, so you do have the same values, or you just choose one partner's values over the others. But again, that would theoretically be a between level predictor because it is a common experience to both dyad members. All right, so now that we've kind of gone through the model, we can actually go ahead and we can begin to run it. Before I do, actually, we have our indirect effects down here, and these are where those labels are kind of coming in. And so this is the indirect effect through relationship mindfulness, and this is the indirect effect through dyadic coping from maltreatment, which is WA1 right there, and WB1 is that B path. So this is your alpha path and for indirect effect, and this is your beta path within your indirect effect for the relationship mindfulness. So again, so my coding system might seem a little bit arbitrary, but this says within, and this is my alpha path, and this is 1 for the first variable, which is relationship mindfulness. And then this is within, and then this is my beta path, and this is for the first variable, relationship mindfulness. And then obviously within, this is my alpha path, and this is my second mediating variable. So that's how I code it. Again, it's incredibly arbitrary. You can create whatever coding system that you want. Right? And you'll notice I have these paths coded as well. Again, we're not necessarily going to use that in this analysis, so you can kind of ignore them. But you will, if you wanted to calculate like an indirect effect at level 2, or I guess at the between dyad level, you could absolutely do that. All right, so what we're going to do is we're going to run the model. And so you will see that we're going to be running 100,000 iterations. And so because I have all the processors working and I have a newer computer, it can cut through these kind of really quite quickly. But if you have an older computer or less powerful computer, this might take a little bit more time. We're not necessarily going to go into like interactions in this demonstration, but once you start including interactions here, it can get some models will run for half an hour or 45 minutes just on their own, even with a new and quite powerful computer. All right. And so speaking of that the interactions. That's actually why I tend to prefer Bayesian estimation. One's maximum likelihood with latent moderated structural equations (LMS). It does fairly well, and I've used it in some of my research, but what I have found is that there's a lot of convergence failures when there are multiple interactions within the same model. So that's not something we're testing in this example. But once you get, two or three or four, latent interactions within the same model, maximum likelihood, it tends to have a lot of convergence issues, whereas Bayesian doesn't. And they essentially give you almost the exact same output, the exact same result, but Bayesian is computationally much less demanding than those other two. And so I will actually briefly go over to the diagram because you'll see here these four are observed variables. But in Mplus, and what makes Mplus so great with multi-level SEM is that the within part and the between part are latent variables. All right. So Mplus does not treat these as observed variables, which I believe other softwares do use. So I believe HLM, I haven't used it since my doctoral program, but I believe HLM, when you're disaggregating, might not use latent variables. When you disaggregate, they're kind of viewed as observed variables. And so what the latent variables afford is it accounts for measurement error. And so we're actually going to get more precise parameter estimates because we are accounting for measurement error due to using a latent factor. So that means if we are, testing an interaction, let's say I was interested in child maltreatment and the relationship to relation quality moderated by dyadic coping, I might think to create just a normal interaction like you would in Mplus and or in any other kind of software program, thinking I'm using observed variables. Well, I'm not. I'm actually multiplying two latent variables by one another, which means you have to use LMS or you have to use Bayesian. And again, I found that Bayesian is much more computationally efficient and it doesn't lead to those convergence issues. I've actually run in this model specifically, I've run gender as an interaction with maltreatment with relationship mindfulness. So I've tested gender differences across all of these pathways. And maximum likelihood in the LMS approach fails to converge once you added in either two or three interactions within the same model, whereas Bayesian was easily able to handle that. So again, that's another kind of unique feature of Mplus and also a unique feature of Bayesian estimation. All right, so we will go through our output. And again, here, same error mess, I guess not necessarily error message, but warning message about dyads who have the same value on these variables. All right. But again, we can kind of ignore that. So this means we have 372 people. So this does not mean we have 372 couples. It means we have 372 people because this data is in long format. You need to run use long format if you're running multi-level SEM within Mplus. And so you may have even seen my data file is called datalong.dat to remind myself this is in long format. All right, we'll scroll down. We'll scroll down. We want to, again, just generally take a look at our univariate statistics. Do they make sense? Because oftentimes when there's a coding error, I find that coding error not necessarily in anywhere else in the document or in the output. It's almost always within the univariate descriptives, where we have a mean that we didn't expect. We have a variance that is kind of outrageous, either too big or too small. It's the best way that I have found to detect possible minor syntax errors. All right. And so you'll always get this message. And again, if you've done mixture modeling, you're used to a similar message saying always increase your start values. But again, we've run 100,000 different iterations. That is more than enough. Even with Mplus kind of automatically discarding the first 50%, it's kind of like a burn-in period. 50,000 iterations is again, it's probably not required to do this many. You're probably good at 20 or 25,000 iterations. So for model fit information, you're going to get kind of two different ways to evaluate model data fit. You have your deviance criteria, and this, again, this will be fairly familiar to those of you who use multi-level modeling. And then also you have your post-predictive p-value. And what research has shown is that the PPP value tends to be a little bit better, superior to predicting or evaluating accurate model data fit compared to the deviance inclusion criteria. So I tend to use, again, kind of both, but I give a little bit more weight to the posterior predictive p-value. And we want this to be between 0.45 and 0.55. Right, so that's generally the commonly accepted range, and ours is 0.486. And so again, we're well within that confidence interval. And essentially what that means is in the Bayesian estimation that there's a lot of congruence between the Markov chain Monte Carlo simulation that's going on in the background, that they're estimating two or three or four or five or six or seven different chains or of kind of parameter estimates is a kind of again a very general way of thinking about it. And it means that there's a lot of convergence between those two chains. And so if you have a really poor convergence, if your posterior predicted p-value is 0.25, that means those two chains are fairly incongruent with one another. And so that's telling you of some unstable parameter estimates which would indicate that your model is probably misspecified somewhere, or there's a syntax error or something to that effect. So that's really what we look for here. And also in Bayesian, this will probably look a little bit different. We have a one-tailed p-value. Bayesian does not give you a two-tailed p-value. What it will give you is a 95% what's called a credible interval. It is not interpreted the same way as a confidence interval. It's actually a little bit more interpretable, in my opinion. Where at the confidence interval, we're 95% confident that this value that we've estimated is the population value is contained within that confidence interval. So again, it's really, really confusing. It's really, really difficult. People get this wrong all the time. Even when I'm teaching confidence intervals, I have said it incorrectly. And so it can be actually really difficult to kind of nail down. But in Bayesian, you talk about it more in the frame kind of probabilities. And that's generally how people want to talk about confidence intervals, is in probability language. You can't do that. But again, in Bayesian, it becomes much more acceptable to be talking about it in the language of probabilities. And also you will see 1 star indicates significance and it will not tell you how significant. So it will not differentiate p is less than 0.05 or 0.01 or 0.001 if you are used to that from like a frequentist perspective. All right. It will just tell you that it is significant. And we also we'll take a look at the estimates here, but essentially we don't want to trust these confidence intervals because they can potentially be biased. So we are actually going to scroll down and we are going to look at our credibility intervals. See, I even just messed it up right there. We don't want to trust our credibility intervals up top. We want to look at our credibility intervals with the in the output, and this is you get that output by using C interval with HPD. That's what that the syntax to get these confidence intervals are. So we will see that at the within level, childhood trauma is predictive of relationship quality. So that means dyad members, so men and women, who have higher levels of trauma also report having higher levels of or lower levels of relationship quality. All right. And so again, this effect is again within a dyad. So it's interpreted as dyad members who have higher levels of childhood maltreatment also report lower levels of relationship quality. All right. And again, this can be thought about as relationship quality that is unshared with their dyad, with their partner. Right, so these are going to be their unique individual-based perceptions. The variance that is at level 1 is kind of deviate separate from or deviated from what is happening kind of at level 2. Right. We also find that common dyadic coping is significant. And this would be interpreted as, dyad members who report higher levels of common dyadic coping are also more satisfied or happier or report a higher quality relationship with their partner. Okay. And we see that relationship mindfulness is not a significant predictor. All right. So the confidence interval includes 0, would be somewhere right in there. And that means, again, non-significant. So over here, we see that when dyad members, when men and women have higher levels of trauma, it doesn't necessarily mean that they are going to be or have lower levels of relationship mindfulness, right? And then likewise, we have no effect when childhood maltreatment predicting common dyadic coping. So that means, again, as levels of trauma or maltreatment increase for either dyad member, and again, this is kind of accounting for gender, so the effects of gender are already kind of gone. When those dyad members report higher and higher and higher levels of trauma, it doesn't mean that they report lower levels of common dyadic coping. Okay. And so here, this means we have a direct effect, right? Here, between our IV and our DV, here is a direct effect between our mediator and our DV, but we do not have a direct effect from our IV to our mediator, which means that our indirect effect is going to be non-significant. I don't even need to look at the output to tell you that that's going to be the case because we've kind of broken the mediational chain, right? And so we can see that age has an effect. So the older that dyad members are, the less that they engage in common dyadic coping. We see no other effects up here for age and or gender. And we see gender here actually predicts relationship mindfulness. And I believe I have gender coded as males 1 and females 2. So that means going from male to female, they have higher scores on relationship mindfulness. at this level, 0.846 units higher on relationship mindfulness. All right, and then we can look at the between level. And so we have common dyadic coping once again being significant. So this means that when couples have higher levels of common dyadic coping, that means that they are happier in their relationship. So notice the subtle language shift that I used. Rather than partners or individuals, I'm saying couples. All right, because this is at level 2. This is at the dyad to dyad differences level. All right, so we're not necessarily comparing partner 1 to partner 2 now. We're comparing dyad 1 to dyad 2 now. And so we actually have common dyadic coping being significant at both levels. And so essentially what that means is it's a predictor of discriminating couples who are really, really happy from couples who are less happy. You know, they're going to have lower levels of dyadic coping. And it can discriminate when partner one, it can discriminate between partners within a dyad. So that means common dyadic coping, it's associated with partner to partner differences and dyad to dyad differences, which again is really, really cool and can actually be exceptionally useful for advancing theory and again understanding the effects that are actually likely happening in the real world and understanding partner differences and couple differences, which if you've talked to any couples therapists, they will absolutely tell you that there's couple to couple differences and partner to partner differences on these constructs. At the between level, relationship mindfulness is not predictive of common dyadic coping or relationship quality above and beyond common dyadic coping. We see children is not a significant predictor. Um, Actually, in the first model, or when I had shown you this diagram and I put children up here, I actually had forgotten that I had relationship mindfulness being regressed on children. It will, I mean, you should actually get the same effects if this was a with statement. So it actually doesn't really matter here. But that was I thought I had included it as a covariate, not as a predictor. But again, either way, it doesn't really matter because again, it's a covariate and it's not something we are trying to answer. And so here are the new and additional parameters. These are the indirect effects with your credibility intervals. And as expected, they are non-significant because we had no significant direct effects from maltreatment to either relationship mindfulness or common dyadic coping at level 1. All right. Because again, child maltreatment only exists at level 1. Perhaps if we were thinking about like intimate partner violence, right? I think that's something because it occurs between partners, it occurs within the context of that relationship. We could pull that apart and that could be really, really interesting. But nonetheless, we cannot do that with childhood maltreatment because again, that theoretically makes me really uncomfortable. Statistically, we could, but again, it doesn't make a whole lot of theoretical sense. So hopefully this has been helpful in understanding multi-level structural equation modeling with dyadic data.